Hello, Gur. How are you?
I'm good. How are you doing?
I'm very good. Welcome back. You always seem to be here in this corner of the gym.
Of the
at
gym,
Superbooth.
exactly. Unfortunately, I don't go to the gym myself very often, but yeah, it's an inspiring place.
Well, here you
isn't
are.
it?
You're in the gym now.
Yeah.
So, yeah, what are you showing off here today? I think you've got a couple of things we're going to look at.
Yeah, we actually have quite a lot of stuff this year. We are going to start looking first on the Buchla modules, the collaboration between Tiptop Audio and Buchla. We have come up with new modules, especially for Superbooth. We were rushing to bring it up and make it work. And deadlines are always a good thing, I guess, in that fact that we're pushing things out.
So this is a true collaboration between you and Buchla.
Yeah.
And so what we're looking at here are like-for-like modules of the pre-existing Buchla range that existed before, correct?
Exactly. These are reissues. We really try to consider this as we are reopened Don's factory, Don Buchla factory.
I see.
And trying to remake everything with whatever is available these days as far as electronics, and we are trying to keep it as good and as original as much as possible.
I see. So you're not necessarily putting any new features into older modules?
Mostly not.
Okay.
But here and there, if we can, then we would do that in parallel to the original function, not instead and not in series. In fact, in order not to affect them, we're not trying to make anything better. We are sometimes adding stuff that helps the user get a little more out of what these things can do, but absolutely not instead of the way they originally were designed.
Okay.
So really, this year, what we are getting a lot of attention for, and it's quite obvious, is this beast.
Yes.
It's called the 248 MARF. That's how it's known if you go online. It's a multiple arbitrary function generator. And it's really hard to explain what it does because it just does so much. And in Buchla world, the way you patch things is quite interesting because it's not a standard synthesizer. It's a synthesizer that was built to make anything from sound design and up to tonal music, and of course everything in between. So however you patch it is what you're going to get. And this thing is it's kind of a mix of everything. It's can be considered a sequencer. It can be considered an analog switch. It can be considered a quantizer. It can consider an envelope, a slope generator. It just does so much. I will go a little bit on the features, just showing them part by part. Obviously, I'm sure that whatever I'm going to explain here won't be enough for the listeners to really understand exactly what it does, but maybe it can give you a little bit of an idea. So we can look at it as like three main functions. This is one function area. This is a second area, and this is another area. Okay,
I didn't realize this was actually part of it as well over here.
Yeah.
It's quite a large module, isn't it?
It is actually a very large module. If we start on the right side, this is where you have your faders. With this, you generate voltage, pitch, whatever going to come based on the setting of those faders. And on the bottom, we have time. And time is defined per step. Per step. I don't want to say the word step because then it means it's a step sequencer, and it's not necessarily is. Okay, so it's defined of a stage. Okay, so the higher you go, the longer it will stay at that stage. And you can apply discrete values to each of those. And to do that, you do it in this section. So when I want to work on this device, I'm going to go, this is the main switch that I'm using to go between the stages. And as you can see, as I go through them, you can see all the lights here are changing per stage as they've been programmed before. Okay? And here, what we have a lot of functions. These are functions that define the range of voltages coming out. This is a quantized or non-quantized output. This helps to set areas of loops within the range of the 16 stages. So you can theoretically have, for example, one range from 1 to 6 and another range from 11 to 16, and they can play simultaneously. They can become polyrhythmic. Yeah, I guess it's a polyrhythmic generator as well. That's another function. And over here we have the time range, and this is a time slot that we can apply to each and every stage over here. So this is like the cockpit. This is where you set each stage. And of course, if you want to apply one function to all, you can do that by holding the stage button and just applying, let's say I want a full range, voltage and everything. So now I have full range over all the stages. You can see that the slide is now on.
Yeah.
Okay. Or if I want, let's say I want an offset of 4 volt, I'm going to hold it and apply this, and now I got 4 volt all across.
Oh, I see. So we're actually choosing the stage number here.
Exactly.
And then all of these apply to that specific stage.
Exactly. Once we hold it.
Once we hold it.
If we do it just manually, one by one, and let's say I go to stage number 2,
yeah.
and I'm going to apply an offset of 6, then only stage number 2 is going to have a voltage offset of 6 volt. So this is the center. Gates are, again, they are coming in 2 outputs, or how should I say? They're coming from a core that generates 2 gates, and you can decide how many you want for each of the stages. Okay, so as you can see, as I go through the stages, some of the gates of output number 1 turn on, and some of the gates of number 2 turn on, and you can play with it and have them coming out of the jacks over here. Okay, they're a little bit hard to see because of the cables.
Okay. So these are all the outputs for the module here.
Exactly. So there's a program output. So this is a section and another section. So you can think of it as let's for a second call it a sequencer, right? So let's say it's a sequencer that is driven from those 2 sections. Okay. However, it share the same faders. So then if you have those 2 internal sequencers running at different rates, you start getting all kind of interesting polyrhythmic sequences.
Yeah.
But they are still related because the faders are set in a certain level and they are feeding from the same faders. And if we go down here a little bit, we can see that each of those sections have, it's it's a bit cloudy here. So we can see that there's time multiplier, and that's basically the pulsar. Don Buchla used to call those things the pulsars. They're the things that generate clock in the system.
That's right.
And it's a super complex section because the pulsar can be controlled in various ways, and there's 2 of them. So it's really not a step sequencer where you apply a clock and a reset, and or you have just an internal clock just ticking, a 16th note sequence. It's nothing at all like that. It's really made to create very odd and interesting timing, and they are voltage controlled, and they can be manipulated both in real time and as a program. Now, on top of this, we're going back to here to our cockpit. So we said that all the outputs can output voltage. Now, when we are set to any of those, we're going to output steps of voltages. But we also have slops, and those slops are you can theoretically build, for example, an envelope. It can be a typical ADSR style envelope. That's what's in the user manual from 1977.
Well, by setting.
For example, you would go to step number 4 and you would set it as a slope. So now what's going to happen is that it's going to play, let's say you have those faders down here, it's going to go ta ta ta, and then go up here.
So we get a bit of slew.
Exactly.
I see.
So, and then imagine if you could do it to all 16 stages, you can get really, really interesting modulation because, and it's all visual, get the visual aspect through the faders. And then come another interesting part, and that's the external inputs. Okay,
so we've got 4 of those.
So we got 4 of those. And I can go, and let's say I want stage number 5, okay? I go to number 5, and I say I want to use external. Now external means that number 5 now, and that's going to be this fader, okay? Depends on where I set it in the scale. You can see you have A, B, C, and D over here. And these are the inputs. It corresponds to the inputs, A, B, C, and D over here.
Yeah.
So whatever is going to, let's say I put it on D, okay? So whatever comes on in D will get added and sent to the output.
Wow. So you could be sending an LFO into that, or an
envelope,
or any other kind of voltage, and it gets added to that.
Exactly.
On that particular step.
On that particular step.
Fantastic.
So you can have, it's pretty wild, isn't
it?
Is. Yeah. So you get like, a step, and then you got a ramp, a slope, and then you got an LFO from an external source, and then you go back to normal steps. It's really complex.
Really interesting, isn't it?
Yeah, very, very interesting. And when we start working on this, I said, this is going to be a huge panel, and it looks super primitive. It's 1970s technology. Is it really worth this entire space? And again, once we build it, it's just like it blows our minds with the things we are able to do it. And to be honest, it happens with a lot of the other modules here in the system. It's really when you start adding more and more, you get more and more of the picture, of the whole picture that Mr. Buchla was designing for. So
I can imagine just the way you're explaining what this can do and the approach and the ideas behind it, and then you multiply it by everything you've got here, because they're not just oscillators, they're not just envelopes.
Exactly.
They've got such a different approach.
Absolutely. And it's just, it becomes so rich and so complex. So, and we were talking about adding things to it. So we were saying, okay, this is super complex already. What happened if I made something and I really like it and I want to keep it and I'm playing live this evening? So we decided to add presets to save the states. Yep. And that's something that...
that's not something you see common.
Yeah, that's not something you see common.
So that's here.
Yeah, and these are these guys, and you can go and you can select. You go and you say load a preset, and you are in a different place. Wow. And those functions, again, we stopped playing with that, and then was like, oh, that's great, because it's you not only can save your work, you can also switch between them, and the whole thing, it just changes, and you get wild new results. And then what we don't have on this panel yet, but the next versions will have it, because this is still just a first prototype, is we're going to have music scales on this. So there's going to be, you will be able to select the scale and the key. And since you are able to quantize, you're going to have quantization coming. Excuse me? Yeah, we're in the middle.
So it's okay.
Yeah. So the quantization is part of the thing is built in, but having the ability to actually select scales and keys is an addition.
I think that's really useful, because despite the amount of kind of semi-generated randomness that you can get, although it's not really random, it's actually very sort of mathematically created, going back and being able to get to scales and things like that, and something maybe a bit more musical at times, can be quite useful.
Yeah.
I can see why you would do that.
Yeah, so I think our listener will say, musical is a big term.
Well, yes, okay, fair enough.
Yeah, but yeah, I mean, once you have the quantization, obviously it's there. It's like then why don't use it to its full extent? And to move even further with that, we have added the art outputs. There's two art outputs, one here and one here, which means that if you're using the MARF with, for example, the 259, which has art inputs, here you go. You have really well-tuned oscillators with a very robust communication between the sequencer and the oscillator, so you get the notes you're really expecting to get out.
Yeah. So this art technology, this is the same art technology as we would see over here, which you've implemented in here, which we're going to talk about.
Right, exactly.
But,
exactly.
Yeah, it's the same.
It's the same thing. I mean, our art is really just a far more advanced and tailored version of MIDI, I would say.
Okay.
You know, I sometimes hear people say, hey, why didn't you just put MIDI input in here? Well, MIDI was never meant to be built into synthesizer, to modular synthesizer, I mean. And the way it's been implemented is a complete mess. It's really, you know, some of the manufacturers have been using it because there was nothing else, and we are trying to make an alternative that that makes it easier, makes it an easier workflow using the same cables. It's just become like CV and gate. It's nothing more and nothing less. And it's needed because CV and gates are wonderful as they are, but they're super fast. And you can never have a digital signal that can be as fast as CV and gate. So timing is super critical in this aspect. And the second thing was about the plug themselves. You know, if you have MIDI, then you have those TRS. It's a different jack, but it looks the same cable.
Is it TRS-1 or is it TRS-2?
Do you have the dongle? You don't have the dongle.
Yeah, I get that. I've been in that world of pain a little bit.
Yeah.
So
Did you
I
set the channel, the MIDI channel? Here, there's no MIDI channel. It's just like one V octave. You plug in, out. That's it. It's working. It's simplicity. People ask me why didn't you use MIDI? I said, you know, technology. That's the word. I mean, we can be stuck in the past with that, or we can move forward.
Yeah.
Now I understand obviously that there's a lot of gear with MIDI that want to communicate with that stuff, but it's really not a problem to convert MIDI into art. And since art is so fast, it can eat MIDI data without any latency, without any issue. So the MIDI will choke far quicker than the art will.
Right. Interesting.
Yeah, so in that sense, it's also showing, that art is open to be placed not just on the oscillator side, but also on the generating side. So, here's let's look at this, for example, as a sequencer. Here you got a sequencer with art outputs, right? So, I hope that over time, people will get it, people will understand the benefits, and we will start to see this signal being added to more sequencers and more devices that people are making.
So can that technology, the art technology that you have, can it be, I guess the word is licensed to other manufacturers?
It's absolutely, it's fully open.
It's fully open.
Yeah,
Okay.
The documents are there. Anybody who want to use it is just fully welcome. It's way cheaper than any alternative. That's another benefit of it.
Right.
You can stack it. You can just stack cable and go to other destinations.
Right. Yeah.
There's none of the limitations. It's just, again, it's in the workflow of the modular. It's not something that is like a foreign object trying to fit in a hack. It's not a hack. It's a fully tailored signal, and it's actually super simple to use. And that's the whole point of this. Yeah, so we're going to move next.
Okay.
So the next one is our 230T. That's the triple envelope follower.
Okay.
And that's another wonderful vintage, the Don Buchla design. I mean, it's simple in the way it works. What I like about it is how well it works. I've been trying envelope followers, from other designs in the past, and I really like this one. It's just super sensitive. And this sensitivity allows you to really pick up any noise. You put a microphone, even sometimes when you are rotating a knob, it can turn on some CV out. It's just so sensitive. The decay time is set really well. It has pulse output and CV outputs. Then the pulse outputs are used to detect a threshold in the CV that's generated. And they can either generate a trigger signal or a gate signal that is held as long as the CV is high.
Oh, okay.
So
a bit like sample and hold in a way, in the way that it's. No, I'm getting that mixed up. Yeah.
Well, it's like a comparator. It compares the voltage of the input CV, and once the CV passes a certain threshold, then the gate fires.
Then it fires. Yeah.
Okay. And that's very useful, if you have something coming in here and you take the gate out and you then trigger other things in the system. I've used this yesterday with a feedback loop where I take it and I just take the CV out into the same source that I was controlling it, I was playing from, and it was making really wild stuff. So again, it's a simple module, pretty easy to use. but does a lot and complement the system in the way that all the modules and that are here until now have been done.
I guess when I've used envelope followers, I've always used maybe external things, maybe a kick drum I might feed into it, or a contact microphone, that kind of thing. So would that go into the signal inputs we've got here?
Yeah, exactly.
Right.
Now here's the thing. It's the obvious use, right, to use something external.
Yeah.
But actually, it's very interesting to use things coming from the system itself. So if you have a sound generated by the system, and it goes into here, and it's getting analyzed, and then you take the CV and feeding it back into that source, you start getting really interesting things. So, and you, how did I looked at the schematic, and on the schematic, it talks about sounds coming out of the 292. So it was like, oh, I was telling myself, but I would imagine an envelope follower will always be dedicated to a microphone and something external. And you can see again, you need to get into Don Buchla's brain and try to think what he was thinking about this. And I think the way he visioned the use of this was, of course, external signals, but also a lot of things coming from the system itself, being analyzed by the module, and then go to either other sound or even back to its original source of sound. So very interesting, very cool module.
Cool.
And a further extension of the system. Now let's...
So just quickly, is all of this system available now to purchase?
Well, no, the 248, we hope to get it ready for the winter. I can say that this prototype is about 80% already working. There's still more work to do, of course. Fine-tune, find bugs, see things that might, because there's just so many functions, right?
Yeah,
I mean, you need to test this thing for for so much to make sure it really does what it's supposed to do. So we are looking at this for hopefully this winter, maybe even the holiday season if we're lucky. Prices anywhere, we're looking from $650 to $1K US dollars. It's all going to depend on demand, and this entire project is built on demand. When we have high demand, we're able to negotiate good pricing for parts, and we're able to lower the price, and that's how everybody kind of, able to afford something like this. The 230 is probably within the next 2 months. It's finished, it's ready, it's working, it's great. Price point, 200 plus. Yeah, so
US dollars.
So affordable. So this is our 200 system.
Fantastic. You should be really proud of this. This is really cool. And I think it's, it's kind of really noble that you're bringing back all of this kind of technology, the thought processes and the approaches to creating music, however that term you might want to use. So yeah, it's really cool. And then adding some extra nuances in there as well along the way. So it's really cool.
Thank you. Yeah, no, we really, we really appreciate the opportunity that felt in our part to be able to actually make this thing. It's really an honor. So, and we're taking it very seriously, and we're enjoying it. And I always worry that my hobby will turn into my job, and my job will be hard to do. But I've been doing it for many years, and it's great because again, this is something that somebody else made, and when you are working on something that somebody else made, you discover things. You need to get into their mindset, and the way this system works and how well things works with each other is really outstanding, especially in Eurorack. And you could see that a person sat on this for a century, really dialing things to perfection. So we are learning a lot of things over here, and we are really enjoying it.
I bet you are learning some things from here, and then I guess then thinking about implementing it elsewhere.
Exactly.
Some of those things.
Exactly.